Hello everyone and welcome back to Virtual Crafts. In the last video I explained how we can design a full adder using two half adders, and in this one I'll go through the design of full adder using the data flow and behavioral modeling. This method is way easier than the one we saw earlier. I have already explained what a full adder is and what is its significance in the digital logic design in the last video, and we also saw in detail the truth table and logic diagram of the full adder. I will not go through that again in this one. We'll jump straight to the coding. So if you haven't seen that video, you can check it out using the link in the description. So without any further ado, let's get started with it right away. I'll open the QuestaSim and start a new project. Here I'll name this project. You can optionally change the location and then just click OK to create the project. Okay, the project has been created and now we have to add files to it. And this goes back to the first video of this series that we have to add one design file and one Testbench file. And I'll change the file type as system Verilog and click OK. We'll need another file for the Testbench. And that's it. That's the two files we need. So I'll just click close. So we have the files ready. I'll open my code editor and start coding there. You can open these files in the QuestaSim itself and start coding here. I prefer to use VS Code. So I'll just open VS Code. And these are the two files that we just created for the design in the test bench. Okay, to save time, I'll just copy the code wrapper from the last video and then we'll make the changes accordingly. This is the full adder design we coded in the last video. I'll just copy it and paste it over here. This one was using the module half adder. We'll get rid of all the code inside the wrapper. Okay, so this is going to be the same as before. The wrapper has the same number of inputs and outputs. And now we'll add the data flow and behavioral codes here. First, let's see the data flow modeling. We'll use an assign statement. And for a full adder, we have two outputs, sum and carry out. So we'll use a concatenation operator, this one, and we'll concatenate cout and sum together. And what we'll assign to this is the sum of input 1, input 2, and carry in. So this is it. It's that simple using the data flow modeling. What will happen is that A, B, and C in will be added together and the result will be stored in the sum variable. And if there is an additional carry, it will be stored in the carry out as both of these are concatenated together. So with this one-liner, you can create the full adder using data flow modeling. Now let's see the behavioral modeling. In behavioral modeling, we use a behavioral block, always comb, or you can use always at star and then the sensitivity list. But in system Verilog, it's now always comb. I'll add the begin and end statements. Now, data flow and behavioral modeling are mostly alike. In behavioral coding style, we do not use the assign statement. So I'll just copy this and paste it over here. And that's it. This is the full adder with behavioral coding. We'll have to use either one of these for our simulation. So I'll just comment out one of these. Let's say this one. But both of these have the same functionality. As we already have a module named full adder, so I'll rename this to full adder 2. And that's it. Now let's add the test bench for it. Again, to save time, I'll not write the whole test bench again. I'll just copy and paste the one from last video. All we'll have to do is to change the module name in the instantiation as we have changed it in the design. and we'll change it here to distinguish the test bench as well. So that's it. The rest of it is just the stimulus and the displays, so they will remain the same. And this is it for the coding. Let's go ahead and simulate the design. I'll save it and I'll switch to QuestaSim. So I'll just compile both of the files, select both and click compile all. And you can see that both of these files compile was successful. If you have any syntax error, you'll see it here. Now I'll simulate the design, go to work, and simulate our recently created test bench. And then I'll just click OK to open the waveform. To get the waveform window, go to View and click Wave, and you'll get it here. So let's go ahead and add the signals in our waveform. Select all, right-click, and click Add Wave. Move to the waveform window, and you'll see that the signals have been added. Now I'll simulate the design step by step. In the test bench, I've added the unit time delay as 5 nanoseconds, so I'll change it here, and I'll just click Run. I'll zoom in the next step, and I'll just run the whole simulation. So this is it. As you can see in the first entry of the truth table, when both A and B are 0 and carry in is also 0, the sum and carry out are 0. In the next entry, when A is 0, B is 0, but carry in is 1, we see that the sum is 1 now and the carry out is still 0. In the next entry, we'll see that A is 0, B is 1, C in is 0, sum is again 1, and carry out is 0. And in the fourth combination, we'll see that A is 0, B and C in are 1, and this time sum is 0 and carry out is 1. So this is basically the truth table that we saw in the last video, and it checks out from the waveform. And similarly, all other combinations are true as per the truth table. To check the printed table using the displays we added in our test bench, we'll go to this window again. And here you'll see that the whole truth table is printed out with the values of 3 inputs and 2 outputs, sum and carry. And this is exactly the same as the truth table for the full adder we saw in the last video. So that's it. That's how you can design a full adder in either behavioral or data flow modeling. This is it for this video. In the next video, we'll move to more combinational blocks such as multiplexers, demultiplexers, encoders and decoders, and then eventually we'll move to designing a single cycle processor, and we'll go from there. If you like the video, please consider subscribing and hit the bell icon next to it to receive the latest updates. Thank you and see you in the next one.